Right, this is extremely important. I was bottoming this out, and it was still sticking up like an eighth of an inch. And I couldn't figure out why. I thought something was like debris was stuck in there, so I kept digging it, and I may have um, stripped some of these threads. I'm not sure, but the reason why this doesn't sit all the way down here is because you're supposed to put the filter on, and I forgot about that. So you can see that this right here goes into that bolt, and the other piece I think goes right there. So don't be careful. You might strip this out if you forget about this. And don't forget the O-ring. Alright, I've got this set to, I think, 104.5, somewhere there, inch-pounds. The plate for this regulator, I must have dropped something on it, but it got warped, and so I had to hammer it. And so I'm really lucky that there's so many bolts on this thing. Alright, this is something really important. It was actually much worse than this before. I took off the regulator because I actually needed to put the servo body in. And to do that, I had to take off the regulator. But what I found actually is worse than this. I actually hammered this flat after I saw it, but basically the walls are crushing it right, not on this side because this is the flat side, but this side you can see. I thought that maybe I dropped this thing or something, but I don't remember that. Basically what's happening is the walls are crushing it and it's deforming it. Right here it's got a little divot. So I mean, I've actually hammered this flat and then I put it back on for a second time, and this is what happened. So I'm gonna try re-drilling this hole to make sure it's still the right size. But basically what I did before was I cut it with a razor blade. You might need to use like a cut-off saw or something. But that's one thing about this kit that's not right. And I'm gonna try to flatten this if I can, because this is a huge bulge right there, and it looks like it's cracked too, so that's not good. This part I'm going to show you is extremely important. So on my first attempt on here, let's see, okay, right here, they didn't tell me in the directions that the plug had to be flush, and so when I bolted it down using the screws on the regulator body, not only did it destroy this, and also it dented the regulator body. So so the regular body could have not actually been flush with this, and so then you got cross contamination between two lines that shouldn't be. So this is trash. The regulator plate is the only plate that you can actually buy from Honda. All the other plates are either discontinued or there's no ETA on it, so it's the same thing as discontinued. So I tried to save the piece of aluminum that came in the kit, but there was a hole in it and it wasn't centered. I didn't like that, so I tried to smash it together like hamburger, kind of fold it and then make another piece. But that didn't work too well, so what I actually ended up doing was I bought aluminum rods off Amazon. Aluminum solid, I forgot which one it was, but these are really shiny aluminum, so I was worried that it wasn't the same type as this. But I did a test by sanding the original piece right here, and then I sanded the new shinier aluminum, and it sanded the same. So I think that even though that looks like softer aluminum, it's basically the same thing. So how I got that piece right there is I took a rod that was actually smaller than the hole, and I just used my pliers. I used my pliers to cut it, and then I turned the rod, and then I cut it and kept turning it and cutting it. And I could have chose a piece that was about the same size, but what I wanted to do is I wanted to mushroom out a smaller piece to fit it. And so this is pretty close. So I'm gonna smash it in. The size was smaller than this, but I was hammering it until it got it close to that. And so now it's close, I'm gonna smash it in. And this time I'm just gonna make sure that it's flush on both sides. Just in case you need it, the little cotter pins for this kit, if you need more, they're really small, so it's 1/32 of an inch, and that's about as small as they get. You can see it's pretty tiny. So I got 3/8 and 1/4 inch because I didn't know what length I needed. So even a 1/4 inch is going to be too small. And what I did to trim them is use these Lexan scissors for RC cars when you cut the body out. So I use these. And I actually reused the old one because I noticed that the new ones that I got let a tiny bit more oil past the cotter pin than I wanted. So I was able to reuse it, but if I wasn't able to, I could probably smash them flatter so they're as flat as this one that you see. It's probably not going to show up, but basically it lets a tiny bit of amount of oil through, and that's by design because I talked to the guy that did the R&D, and that's what he said. And then this thing, here's the bottom side, and I can feel that it's not perfectly flat, so I'm going to sand this later. But I got this side fairly flat. I use really rough sandpaper, and I'm going to go over it with finer sandpaper. But he said use a file, which I don't have. But this is okay. This is a lot better than it was. When I originally had it, it was sticking up a lot. It was mushroomed out, and that's what caused the damage. This thing has to be flat on both sides. So I'm going to make them flat on both sides with sandpaper and then polish it. But I do have to punch a hole here and then drill a new hole, because the problem was the original hole is bigger than what they want. The smallest drill bit that they give you is super tiny, so rip off a piece of paper and then wrap it around here and then put it into your drill. Alright, so that's the hole I drilled, and the way I got to be really centered was I used a permanent fine tip Sharpie, and I made a little dot on it, and then if you're not happy, just use some alcohol, wipe it off, and then try it again. And then I used a pick as the center punch, and I put it on the Sharpie mark that I made, and I lightly tapped it in with a hammer, and then I drilled it with that with the drill and the piece of paper towel wrapped around it, and you can see it's pretty centered. So now all I have to do is drill it with the 0.125 inch drill bit. Right, so I'm finished with this, and you can see here it's 0.125 inch, so it's fairly flush. It's not perfectly flush, but I'm kind of lazy, so sanded it with coarse grit, and then I finished it with 800 grit, and I drilled that hole too using the smallest bit there. It looks really clean. I drilled it here, then I drilled it from the bottom, and then I sanded everything after I drilled everything. That hole is drilled. That hole used to be that size, but I drilled that, and then the cotter key right here. And you know, one thing that I noticed is when I tested the new cotter pin, I think I actually tested it on a hole that I drilled, so maybe they're the exact same size. So maybe it's not a problem at all, and I just accidentally put it into a slightly bigger hole. So yeah, if you need it, it's 1/32 inch. That's the diameter of the cotter pin. So that's the original cotter pin. I was able to use it. And the only thing that you have to remember is the orientation of the spread out part, because if you look on the actual circuit, the fluid circuit, I think the walls go this way diagonally, so whatever way they go, just rotate this. But the way I cut it, I think it's so short that it's not going to matter, but just in case, just rotate it so it's inside the walls and not going to get smashed on the wall. Okay, so on the engine side, there's this plate, and basically there's 10mm bolts around here, and also there's two long 10mm bolts here that basically I think it comes from like right on where the oil pan is right here, so this might connect to it, I'm not sure, but these two are long bolts and these are all the same size. And if you need to pry this plate off, you can see there's a ledge here. You can use a flathead or a pry bar. There's one here, and there's another one on the other side. So the rear main seal sits in here. Here's the part number. And the thing is, it looks like there's a ledge here. There's a ledge here all the way around, so I don't think that you can mess this up. It basically just sits flush on this inner circle right here. But I don't think you can really mess it up since there's this ledge. Basically, I just used a rubber hammer and tapped it at a slight angle all the way around. And I was right, there's no way you can mess this up, because you can see that it sits on that ledge, or that lip, whatever you want to call it, and so you can actually use that to tell when it bottoms out. So there's no way you can mess this up. Also, something really important that a lot of people don't know is, besides the rear main seal on the engine side, there's this O-ring right here that's the part number, and so that O-ring just goes in there. And then use a razor blade and clean up this surface here and this surface on the oil pan side. And then you're going to put black RTV around here and spread it thin before you put it down and then bolt it back up. And then you're also going to clean it on the engine side. Alright, this is the drive plate on the engine side. And so that one plate I showed you before, that goes under here. But this is all rusted up, so I used a wire wheel to sand off all the rust on both sides. And you can see that I taped up the center part because I'm going to paint everything. And I'm going to use paint that has rust converter. Alright, so this is after one coat, and it's called Krylon Rust Tough. I got it at Napa, but I think you can buy it off of Amazon too. So you can see it looks basically like aluminum. I'm going to do another coat because it kind of I missed some spots here. Okay, so here you can see it on the engine side, and basically 2 long bolts go here and here, and then the regular bolts go all the way around it. And you can see right there, that's where the O-ring goes in, and so the rear main seal is going to seal this part. And then I didn't show it, but there's actually another metal plate that goes around here, and then you've got 17mm bolts here, and you're gonna need 12-point sockets. And this is the oil pan, so the bottom of that plate mates with the oil pan. So make sure, because this is open right here at the bottom, put a plastic garbage bag or grocery bag here. So when you use your razor blade to scrape all this off, the stuff doesn't fall inside to the oil pan. Alright, so the O-ring's on there, the new rear main seal's on there, and I've cleaned up all these surfaces. And I've also put RTV on there. And so I'm gonna have the plate dry and the RTV on there. Alright, so here's the new end cover. Here's the old one. And so the old one I destroyed. The race that was there for the bearing, I punched through it on accident because I thought I was actually hitting the bearing. So from this side, that metal lip right there, I thought that was the actual bearing, but it's not. So that actual lip is actually, it's the thing that captures the bearing. So I'm going to install the bearing printed side up this way. And so the only way to take this bearing out is by pushing on the inner race, because the outer race is covered up by that ledge. So you would punch it out from this side here. So you can see that ledge there, and I thought that was the bearing. So don't do that because this is like a $300 cover. And so you would punch out, take something and punch out that center race, or use a bearing puller. Alright, so I finally finished the plate, sanded it flat, and then sanded it again with 800 grit. It's not perfectly flat on the other side, but it's already been dimpled out because I messed up the first time because the directions didn't tell me to make it perfectly flat on both sides. But it's still sealing. The walls are still okay. So here's the cotter pin I reused. Thing to note is the plate goes on the servo body. Actually, not the servo body. This is the main body. So the regulator plate goes on top of the main body. Then the stator goes on, and then finally the regulator itself goes on top of the plate after you put the stator on. And the stator, make sure you lubricate the O-ring around here. Alright, so final gear here, differential together. So this is I still can't figure out which one this one is. Anyways, counter shaft probably. So counter shaft goes on, and then I believe this is the main. Actually, it's kind of ridiculous I don't know the names of these, but this goes on next. And make sure you lubricate all the races, and it goes into here. And then 4th and 5th gear are going to go on top of this. I just realized something. Not this one, but this, the little teeth on it. Check that for wear, because what I think that is it's a synchronizer, or not sure what it's called, but it's part of the synchronizer. So these teeth here, check it for wear at the top. These are actually made of steel, and they're on manual transmission. They're usually made of brass. So the corresponding part is going to be this, and so you're going to need to check this part too. You're going to check the outside here for wear and the inside for the teeth, and just make sure that they're not worn out a lot. Alright, this is I've got, if this is the secondary shaft, and you can see once again I see that huge gap. I broke that with this because they didn't design this right. When I tried taking it off, what actually happened is this thing started flexing. It started flexing, and so what that does is it makes it so the hole doesn't open up as big, and so it put pressure on here, and it broke that piece off. Because you can see this is complete, so is this one. The safest thing to do now is take these all off, throw this one away, and I've got the new part over there, and so I'm going to replace this, but take all these off and then put this circlip in first. That way you don't risk damaging these when you slide it over here. So this retaining ring goes back on here, and it captures those half washers or half spacers. And I've got to say that I've actually installed this thing backwards the whole time. So you see the gear, it's on the bottom. I had it at the top, and so you can see that the correct way is there's this thrust washer, and it's hard to see, but you can see all the score marks, kind of like brushed aluminum. That points this way. So, and then so the other side should look like this. So this side has the O-rings. So that's what this side should look like. One more look at this thrust washer that was in there. You can see there's the needle bearing. And so this brush side faces towards the bottom, and the opposite side that the needle bearing rides on, you see that it's chamfered on the inside radius, and this is actually a race for that needle bearing. So when you take off the old part, it should be obvious which side is the race. Alright, so secondary shaft is installed with the gear in the correct position. That's what it should look like with the O-rings here. And then on top of here, we're going to put first and second gear, or actually low gear and second gear. So second gear is the smaller one. So you know this goes towards the bottom because there's no spline here. So you can see that there's a spline there. So that faces upwards over that. Alright, so I held this and kind of lifted it up while I spun the sprag gears, the hub and sprag gears, because you have to line up the indexes in the disc here, so it slides over the gear. Not this gear, but the one above it. And how you know it's all the way down is, I think you just look at here, the gap clearance between this and here, because obviously they can't rub against each other. And then this one actually looked like it looked like it wasn't low enough, but I don't think that this spline is supposed to mesh totally with this thrust washer or washer, whatever it is. And this is the race for one of the needle bearings. So this is going to go on top of it, this gear right here. And this faces down, this side faces down. And this side faces up. Okay, so this thrust washer under here, I actually flipped it upside down. I figured the other side's worn, so I'll just flip it over to the side that's not worn. And it's maybe like a new thrust washer now. I'll double check, but I don't think it matters which orientation it is. So this needle bearing goes on top. The gear goes on top with the two needle bearings inside of it. And then on top of that goes another needle bearing on top of it. Okay, so you'll have to spin this so that it goes into its indexes on the disc. And then this needle bearing goes on top. And this needle bearing, I don't know if you can see, but this side has less channels for lubrication. And this side, you see that both ends of those rollers, those bearing rollers, like this end and the inside end, they have a giant gap in it to let more oil lubricate it. So since I see that the race is here, I'm gonna put it here. It might not matter, but at the very least, spin it, and whichever side spins better with less friction, that's probably the best side to use it. So next thing is put in the main shaft, and this side faces up. This is the bottom part, so it's gonna face like this on top of there, and there's no circlip to hold it in. What I do notice is the way you can tell which side you want these needle bearings on is, you know that this side has less lubrication. This side, because the ends are open, have more lubrication. So you have to decide which side needs more lubrication, this side or whatever's touching on the other side. And so that's how I figured out which side I need to flip the needle bearing on. It seems like a trivial thing, but I think it's actually really important because you gotta decide which side needs more lubrication for the needle bearing. Okay, so this gear goes, or this clutch goes on next, and they're almost identical like I showed earlier. I mean, I can't remember, the disc and the plates might be exactly identical. So the only way you can tell which side is which is, see the spline in here? That spline faces upwards. So that's the only difference that I can tell. There's like one or two parts in here that's different from the other side, but for the most part they're almost exactly the same. On top of this, I believe that this goes on, and this should be the bottom. So this is a kind of like a shaft. So basically, you can see here's a shaft and there's needle bearings inside here. And I'm going to double check the needle bearings because, like I said, one side of the needle bearing provides what looks like better lubrication. I'll see which side needs it more. So this should go on top just like this. Looks like it's actually easier to take it apart and slide this first part in. Slide this down first. And then we're gonna slide the rest of the gear on. So you see there's a ledge at the top there. So we're just gonna put that over there. So you can see it's not sitting down all the way. Like I said before, there's indexes on those discs and it has to be keyed in, so you see it went down just there, and I think one more, maybe. Yeah, one more. So now it looks like that's probably the height it's supposed to be. Okay, just when I said that that's the right height, it actually went down one more, so that's the level it should be. Okay, so I put a needle bearing in here, and the one that's got more lubrication is the side on the bottom. And you can see that the wear on this washer, which is the race for the top of that needle bearing, this was what was sitting on here. But what I'm thinking is, why don't I just flip this over? Because maybe this side's less worn or something. This side feels smoother for sure. But I'm going to put this on here. And it spins okay. I'm going to... Let's see. That might spin even better. I'll decide which side I want to put that washer on.